Okay, so this lesson looks at multiplying with polynomials. So we're going to start off with just a nice simple distribution review. So remember, anytime we have just a number or something sitting out in front of parentheses, we need to distribute it to everything inside the parentheses. So the 4 that's hanging out front on A needs to be multiplied by both of those pieces. So 4 times 3x is going to be 12x, and 4 times negative 10 is minus 40. I go back and check, are there any terms to be combined? No. So I'm done. Okay, remember, so 3x times both of those. So 3x times x, remember x times x, I have two x's, so I'm adding those together to make x to the second. So I have 3x squared, and then 3x times 5 is plus 15x. Again, we cannot combine x squareds and x's, so that problem is done. So C, I'm distributing x squared into the parentheses. So x squared times 5x to the third. Well, nothing times 5 is 5. X squared times x to the third is going to have 5 x's there, so x to the 5th power. So that's taking you back to your exponent rules. And then x squared times negative 4x. Nothing times negative 4 is negative 4. X squared times x is going to be 3x's, so x to the third. X to the fifths and x to the thirds don't mix, so that's done. Okay? So what we're building up to here is this core concept that's in the middle. So what we're building to is this idea of not just doing like a simple distribution, but taking two terms and multiplying it by two other terms. So you can see up here, everything in the first set's multiplied by everything in the second set. So this x that's in this first set of parentheses is multiplied by both of these, and the 1 is multiplied by both of these, shown in each of these steps. So x times x times 2, and then 1 times x, 1 times 2. So this is what we should see. We should see x times both of those and 1 times both of those. That's where we get our 1, 2, 3, 4 terms there. Once we're done multiplying, then we combine like terms for our final answer. Okay? All right, so let's do 3 problems down below, and then I'll have you pause the video and do the other 3. Okay? So let's look at 1 together. So I see 2 terms times 2 terms, so I know this x needs to be multiplied by both of those. So let's do that first. So x times x gives me x squared. X times negative 1 gives me minus 1x. And then I also need to take this negative 2 times both of those terms. So negative 2 times x is minus 2x, and negative 2 times negative 1 is plus 2. Last thing I need to do before I finish this problem is combine like terms. Remember, x squareds and x's don't mix, but I can combine these two just regular x's in the middle. So x squared hangs out front. Negative 1x minus 2 more x's is negative 3x. And then I bring my plus 2 down. And that answer is done. Okay, I am going to do a few more in a minute, but I want you to go ahead and pause the video, try numbers 2 and 3, and then you can go ahead and unpause the video when you're ready for me to go through them. Okay, so on problems 2 and 3, on number 2, I have a times 2a, that's 2a squared. A times 5 is plus 5a. Negative 1 times 2a is minus 2a, and negative 1 times 5 is minus 5. I combine my a's in the middle, so 2a squared, 5a minus 2a is plus 3a, and then bring down my minus 5 for my final answer. Remember, a's and a squareds don't mix. Okay, then on number 3, 3n times n is, let me do it different. Sorry about that. There might be a jump in the video. I accidentally pushed a button. Let me change colors here. Okay, so I have 3n times n is 3n squared. 3n times 1 is plus 3n. Negative 4 times n is minus 4n. And negative 4 times 1 is minus 4. I combine my n's in the middle. So 3n squared hangs out front. 3n minus 4n is negative 1n, and then minus 4 for my final answer. Okay, let's look at 2 more problems. Let's look at 5 and 6 together, okay? So on number 5, the only thing that looks different there is that now I have these 2 terms out front times 3 terms back here. So it doesn't make the problem any different, it just makes it a little longer to do, okay? So I need to make sure and take the x times, excuse me, the h times all this back here, and the positive 1 times all this back here. So I'm actually going to do 6 multiplications here. So h times h squared is going to give me h to the third. It's not a very good 3. H to the third. H times negative h is negative h squared. H times negative 1 is minus h. Then I do the same thing with the 1. 1 times h squared is plus h squared. 1 times negative h is minus h. 1 times negative 1 is negative 1. Now I need to go back through and combine like terms, and this is kind of the harder part. You just got to be careful. So I only have this as my h to the third term, so I'm going to bring that down front. I'm done with that. I have a negative h squared and a positive h squared. Those two are going to cancel. I have a negative h and a negative h, so that's going to make negative 2h. Done and done. And then I have a negative 1. There's my final answer. So you just got to be careful on those. They're a little bit longer problems, so you just got to be careful and make sure that you are working carefully. Okay? All right, so number 6 is kind of a tricky problem for some kids because you see this, a single set of parentheses and a squared outside. So the temptation is we just square both terms and we're done, but that's not really what we need to do here. Remember, squaring something means you multiply it by itself. So instead of just multiplying or squaring the two terms, I'm going to multiply 3x plus 1 times itself, 3x plus 1, and I can get rid of my square now. So now I see I'm just doing a regular double distribution. So 3x times 3x is 9x squared. 3x times 1 is plus 3x. 1 times 3x is plus 3x. And 1 times 1 is plus 1. Then I combine my like terms in the middle, and I end up with a final answer of 9x squared plus 6x plus 1. So if you just square the first and last terms, you're just going to end up with everything except for that middle term, which is important. So make sure anytime you see something squared, you write it out being multiplied by itself, and then do your normal double distribution.